So this is a 2019 higher. This is paper 2 question 2. Focus of this question here is on integration. So all it wants me to do is find the integral of this expression here. Now one thing to always remember is we always want the terms written in the format of ax to the power of n. So written in terms of powers so that we're able to then integrate it term by term. Now this one's fine, it's just a constant. Technically there's an x to a 0 there, but we'll deal with that when it comes to it. This one here is written in the right format. This one here is not. So I've got to figure out how to write square root of x in terms of a power. But that's something we should remember from National 5 when we did surds and indices. So what I'll do is I can rewrite the whole thing as 6x to the power of a half. Remember, square root of x we write as x to the half. Take away 4x to the negative 3 plus 5 dx. Now that I've got it written in an integrable form, all I need to do is integrate each single term on its own, one at a time. So integrating this first one, remember what we do for integration is we raise the power by 1, so to the power of 3 over 2, and then divide by that new power, so divided by 3 over 2. Same for this next one, so take away 4x, now it's to the negative 3, so just be careful here, remember raising that by 1, it's to the negative 2, not to the negative 4, it's a common mistake you see. We then divide by that new power of negative 2. We then have plus 5x. Integral of a constant just becomes that constant plus x. We then have plus c, a constant of integration. An important part of the question, you have to make sure you include the plus c. That plus c shows that you know there could be a constant there. We don't have any conditions with which to find it, yes, but it still could exist, so we have to make sure it's there. Then we start to go along and simplify each term on its own. So dividing by 3 over 2 is the same as timesing by 2/3. So that one there then gives me 4x to the 3 over 2. It's then going to be take away, so 4 divided by negative 2 is negative 2, so it's minus minus. So that then becomes plus 2x to the negative 2 plus 5x plus c, and that there is your final answer. It's not asked for it in a set format, it's not asked for it in terms of positive indices only or roots. That's the way it wants it. We're happy enough with that. Job done. Now if you wrote it in terms of square roots and positive indices, you know, it wouldn't make a huge amount of difference. Just be careful if you make mistakes, because if you make errors when you're doing that, you could lose marks. So just watch out for that. Good idea to stop at this point if it doesn't ask for it in a set format. Now this question here is actually worth 4 marks. First mark is for writing it so that you have 6x to the half, so it can be integrated itself. Then the second one is for integrating this first term and getting to there. Third one is for integrating the second term and getting to there. And then the fourth mark is for completing it, so essentially doing the third term and including your plus c. You do not get that final mark if you don't have the plus c. Now it's not going to be penalised if you don't have it written when you do this one and this one, but in the final solution it must be there, otherwise you lose that fourth mark, and it's a silly, silly mark to lose. We know to do the plus c's from classwork, we know to do the plus c from everything we've done in terms of developing our skills of integration up to this point. Don't lose the silly mark for something as simple as not putting a plus c. Alright, remember, indefinite integrals like this, plus c. Definite integrals, we have limits, we can find an answer. Indefinite, we put a plus c, we have no conditions with which to find it, so we have no relationship between y and x, i.e. this doesn't say y equals that, and then we get a coordinate. So we just leave the plus c, job done.